Deal 100 numbered cards, one at a time, around 4 seats. Card 1 to seat 1, card 2 to seat 2, and so on, round and round. Now, which seat gets card 73? The slow way is to actually deal all 73 cards, counting round and round the table and praying you do not lose your place somewhere in the middle. But you never have to do that. The dealing repeats in a tidy circle, and that repeat is a shortcut hiding in plain sight. Watch which cards each seat collects. Seat 1 gets 1, 5, 9. Seat 2 gets 2, 6, 10. Seat 3 gets 3, 7, 11. Seat 4 gets 4, 8, 12. Now divide each card number by 4, the number of seats, and look at the remainder. Seat 1's cards all leave remainder 1. Seat 2's leave remainder 2. Seat 3, remainder 3. Seat 4, remainder 0. So there it is. The remainder, after dividing by 4, tells you the seat directly. Remainder 1 is seat 1, remainder 2 is seat 2, and so on, with remainder 0 meaning the fourth and last seat. No dealing needed at all, just one quick division. Back to our question. 73 divided by 4 is 18, remainder 1. 18 full rounds of the table and then one more card. Remainder 1 means seat 1. Card 73 lands on seat 1. And we found it with a single division instead of dealing out 73 cards by hand. The 18 whole rounds of the table simply did not matter, because each one brought the deal right back to where it began. Here is why the big number melts away. Every 4 cards the dealing comes full circle and lands back on seat 1, so a complete round changes nothing about where you end up. Only the leftover cards, the ones past the last full round, decide the seat. That is exactly what the remainder is. Divide by the cycle length and keep the remainder. This runs anything that repeats. The days of the week are a cycle of 7. What day is 100 days after a Monday? Do not count 100 days. Divide by 7. 100 over 7 is 14. Remainder 2. 14 whole weeks bring you right back to a Monday, and then just 2 days more. 2 days past Monday is Wednesday. Exactly the same trick as the cards. Only the cycle changed from 4 to 7. So whenever something repeats on a fixed cycle, seats around a table, days of the week, hours on a clock, do not count all the way to the target. Find how long one full cycle is. Divide your number by that cycle length. Throw away the whole loops, because they always return you to the start. The remainder that is left points straight at the answer. Your turn. This sequence rotates its digits and repeats every 5 terms. What is the 100th term? Divide by the cycle of 5 and read the remainder. Pause and try. 100 over 5 is 20. Remainder 0. 20 complete cycles with nothing left over. Remainder 0 means you land exactly on the last term of the cycle, the 5th one. So the 100th term is 5, 1, 2, 3, 4. One more. A clock face is a cycle of 12 hours. What time is it 100 hours after 3 o'clock? Same idea. Divide by 12, pause and try. 100 over 12 is 8, remainder 4. 8 full loops of the clock bring you back to 3, then 4 hours more. 3 plus 4 is 7. 100 hours after 3 is 7 o'clock. Dividing by the cycle and keeping the remainder runs an enormous amount of the world. Clocks and calendars, work rotas, seating plans, repeating schedules. Computers lean on remainders constantly to wrap numbers back around. Once you spot the loop, the answer is only ever one division away, no matter how big the number looks. So when something goes round and round, do not count all the way to it. Divide by the length of one loop, throw away the whole turns, and keep the remainder. That leftover lands you exactly where you need to be. That's all for this video.